So the triangle works the same way as the other triangles. You cover up the letter that you want to find, and it gives you the formula. So, what is the concentration if 5.0 moles of sodium chloride are dissolved in 500 milliliters? Okay. So identify the letters that we have in the question. What letters are we given? C, N, or V?
C. No, my bad.
We're given N, that's that value, and V, except we have to change it to liters. How do you go from milliliters to liters? Divide it by how many? 10, 100, or 1,000? 1,000. So, 500 milliliters divided by 1,000 is 0.5 liters. So now that we have the volume, we can find the C. C is 5 divided by 0.5. So what's that concentration? What's 5 divided by 0.5? If you 10. Ten moles per liter. That's the concentration. Yeah. How many moles are there in 2.5 milliliters of 2.0 moles per liter solution?
By C.
N divided by C. So
Equals 15 divided by 4.
3.75 liters. So if 1 liter contains 4, we need almost 4 liters to get 16. Awesome. Okay, first thing I want you to do is balance this equation. So we're given concentrations, we're given volumes, we have to figure out how much precipitate we can make. There's one piece of information we need to put in here before we can finish and start doing our math. Chris?
The limiting factor.
We've got to figure out which one's the limiting factor. But what do we need to know about silver chloride?
They're both AQ.
No, that's a solid. Silver chloride is a solid. How do we find mass if we know the number of moles? What's the other piece of information that you can calculate just from a formula? Oxygen is 16. Hydrogen is 1.01. So water's 18.02. Good. Molar mass. So what's the molar mass of silver chloride? 107.87. 107.87 plus 35.45.
143.33. I'll just talk first. I'll just leave. It's fine.
All right. So we know C, we know V, so we can calculate N. All of our theoretical yields to date have been mass, molar mass. This one is concentration and volume. You still have to figure out moles. You still convert to moles of product, figure out which one is smallest, and then you can calculate your theoretical yield. So, N is going to be equal to C times V. So let's figure out our moles of silver nitrate and our moles of sodium chloride. Okay, what about the second one?
Decimal 0.75.
All right, so these are the moles of starting material. Now we have to convert them to moles of product. What are the coefficients in front of silver chloride? 1. What's the coefficient in front of silver nitrate? So this is the number of moles of silver chloride. And it's the same for sodium chloride. Okay, so which one of these two numbers is the smallest?
The small number is NaCl.
Yep, the smallest number came from sodium chloride. So that means NaCl is our limiting reagent. And we take this number of moles and we multiply it by 143.33 to figure out the theoretical yield or the maximum mass. It's the same thing. It's 12.01 and 3 oxygens, 40,
Sorry.
32, 48. Add those numbers up and that's our molar mass.
Do you have to write the AQ and S?
Normally, yes.
Oh.
If it's a perfect, if you're looking for a perfect score, yes.
Oh. What does that mean?
197.34?
Beautiful.
Yeah, that's what I got.
All right, so
Oh, damn it, I don't have
calculate your moles of starting reagent. We've got the moles of starting reagent. Convert them to the moles of your solid product. So times, these are nice and easy. They're still 1/1. Which one of these numbers is the smallest? Correct. So barium chloride is your limiting reagent. Take this number, multiply it by 197.34 grams per mole, and you have the mass that we can theoretically get if everything goes right. Say that again? 3.232 grams. Sweet. All right. Josh, pick a number between 1 and 3. 2.5? All right, so Dudley did this experiment. And he managed to mass out 2.5 grams of product. To figure out his percent yield, we take 2.5, what he got over what he should have got, times it by 100. One of your products is always going to be a solid for these types of reactions. This one's barium carbonate. How much? 77.4. So he had 77%. Maybe he should have been working with Hussein.